So in this video, I'm going to do something quite ambitious and go from a very simple model that testing produces information and then try and understand why we might think that we can automate testing and how we got to that position and how we can actually reframe our models so we don't think in those terms anymore. And we're going to get to something like this. So we often hear that testing is a source of information. We shine lights on the darkness of a project. We are the lighthouse that protects the coast of software development. We are torch holders, blah, 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 blah. We illuminate the whatever, right? We're told that testing produces information. So one of the things that when we hear those kind of statements is we should try and unpack them to understand what is meant, or at least build our own model of that. So I have a model of that in terms of how does testing produce information? Well, so information is different. For me, information is something that essentially surprises me or causes me to reevaluate my model. Very often we're presented with data. When you're given data, you look at it and go, oh, okay, yes, I understand that. That's what I expect. That's data. You look at something in the data and you go, wait a minute, what? That doesn't match what I imagined. So your model changes because you're comparing this data against a model. You're trying to understand it. Data in itself has nothing there to understand. It's letters, it's numbers, it's stuff, it's data. So only when we process it and interpret it that it actually becomes information when we compare it with our model. It's a simple way that I have in my head of looking at this. Testing essentially produces data. We produce observations. We produce the screenshots. We produce stuff that happens when we do something. We document that. And we collate all that into a model to help people understand what we have done. That's why we tailor our communication to different people so that it is important for them. It is information. It helps them. It changes their model of the world. And some of that is to advocate for risks, or advocate for customers, or advocate for problems. There's sometimes some sort of agenda behind that from testing because it's information. We're trying to convey some information that we think is important. And there's a risk there because it's information and not the raw data, because no one's going to look at all our raw data, that we have selectively produced that and we might miss things out. So we might not raise problems that are super important to someone else because it's in our data, but we didn't really treat it as information. It didn't seem important to us. So there's some sort of risk in there. But regardless, for me, testing produces information through that side effect of generating data and interpreting it and modeling it. And that's a very important process because it's very hard to make that an automated process. So when we start talking about test automation and automating testing, it's understandable that people are going to argue about that. So let's look at this testing process in a little bit more detail. So this is a fairly organic model of testing. What I'm basically saying here is we work from a model, and that's everything we can get our hands on. The requirements, the documentation, the structure of the application, how it's architected, the infrastructure, the flows through the application, the user flows, the risks that other people identify, that we identify, the parts of the entire problem scope that we want, coverage, information upon, the whole thing, right? That's our model. That's what we work with. And that will change over time. And partly we build that model up by looking at that model we built, coming up with ideas, then comparing those ideas against the system. Exploration in one way to explore our model in terms of how it relates to the system. That's pretty much what testing is doing. We're comparing a model with the system through a whole bunch of different ideas and different ways of getting those ideas and different ways of approaching it in terms of priority and different ways of tracking coverage or heuristics for deciding what to do next and ideas, how we're coming up with ideas. And then what we do is, given that model, which includes all the observations we've made and the results we've made, we communicate that as information. That to me is a high level view of a testing process. It's not the testing process that I was taught when I was growing up as a tester. Now this is much more like the model of testing that I was taught as a young tester. So we have a model that we work from. It wasn't strictly stated as a model in those days, but that's how I interpret it now. So we have requirements. We have the user documentation. We have examples of how it's going to work. We have the flows through the system that we expect users to have, use cases. We have all this stuff. So we analyze that. And because what we used to do in testing was a very formal process, we would come up with identified conditions. They could then be reviewed against the requirements or whatever model and see if we'd done it well enough. Then we would take all those conditions and build test case for it. And a lot of this was because we were doing this in advance of the system being ready. It was not possible for us to take our model and explore and compare it with the system because the system wasn't ready. So we did this in stages because it was going to take years before the system came out. So we did this in stages so that we weren't waiting until the system came out before we considered how we were going to check if the system was good enough. And that led to a lot of these formal entities that we could then model separately. So we could model conditions separately from test cases. We didn't need the concept of ideas, which we very quickly then checked against the system and explored against the system to see if they were working, which fed back into our model, because we didn't have that system there. So it led us to pull things out. So we've got conditions, which then we collate into test cases. We can do a lot of that. Then as we learn more about how the system works, we can start building scripts to say, this is how I will implement the test case. And this is the steps I will take to do it. And these are the things I will look for to see whether this test case has been met, to then determine whether these conditions have been met in the system. And we'd call that test analysis. Then we'd have the notion of test execution, where we take our scripts, we put them into suites as prioritized, and then run them and see what the results were. And very often during that process, you discover that your test scripts were actually wrong because the system wasn't built the way that you were told. And then you'd have to argue, is this a defect, or are our test scripts wrong? And very often the test scripts would be wrong, and very often the test scripts were implementing test cases that didn't exist because we'd misinterpreted the requirements. And there's a whole bunch of rework in there. But assuming there was no rework, you would have these scripts and you would run through them as suites, and you would track the results of having run them and report it. Now, that's a very, very linear process that took a long time and was a lot of work because we would document a lot of that. So let's break this down a little bit more. What we essentially had was a very high level process of doing some modeling and discussing the requirements and whatever else we were working with, doing some test analysis to come up with ideas of how we're going to test it, execute those against the system, and then communicate how they would work. Now, at a very high level, this matches on to the more organic diagram that we saw earlier on. We've got a model, we're coming up with ideas, we execute to compare them against the system, then we tell people what we've done. Now, the difference here is that in the organic model, we're telling people what we've done based on the model because our results are feeding back into it. This linear process made the results or the reporting kind of separate from the model because we had too many stages in the way. So if I look at this again, in the process of the test analysis process, coming up with the conditions, coming up with the ideas, grouping them into test cases, at this point, when we get the notion of test scripts, we're really formalizing how we're going to do this. At this point, we could, in theory, start automating. But we had the problem. At the point back when we were doing waterfall projects in the 70s, 80s, early 90s, before we moved on to Agile, very often we were working with green screen applications or working with desktop applications. And very often we were not complying with standards because we had custom controls. We wanted the GUI to look different from everyone else. We didn't have accessibility layers in the operating system to hook our automation tools into. We didn't have green screen terminals that allowed you to automate through them. Even though there's standard VT52, the tools weren't there. And the tools that were there were incredibly expensive. And very often the tools didn't work effectively, either because there were problems with the tools, the scripting languages for the tools were not very flexible, the applications we were building were not very automatable, and we didn't tie that back to make them more automatable because the tools were so expensive and everything else. But coming up with scripts was very easy. Automating those scripts was hard. But what we have done is we've formalized the entities that are in place, and we understand that if only we could automate this, we would have a good chance of doing this. So then for the execution part. Now remember, at this point in the software development process, you have got a very long software development process. A lot of analysis up front, And at the same time as all this analysis is going on, there's a lot of programming work going on. So people don't really care what's happening in the testing process at this point. So we spend a long time doing modeling and analysis and come out with cases and scripts. But the only time people really pay attention is when you start executing those scripts. And you've spent ages building loads of these things. You've got too many. You can't automate. You can't even begin to manually execute or interact through all these scripts in the time you got left. And people then look at how much you're going to try and check and validate the system against and go, we've got too much stuff, we can't do it. And very often you would find problems, because anytime we develop stuff, we have problems. And we then have to rerun some of these scripts or test suites we're putting them in. So one of the solutions for this was, well, let's make the scripts easy for anybody to run, right? Because what we've got at this point is quite expensive people called testers just doing very simple stuff, work that we really want to automate here. So let's really dumb it down, make scripts that are so detailed pretty much anyone can do, which then means to build these scripts is a lot more work. And then if the scripts are wrong, you've got a lot more rework in those scripts. But again, we'll try and keep it more cost efficient because we've got so much to do, and we do want to try and cover a lot of this stuff. And this led to quite a lot of outsourcing to people who were cheaper in different countries, that we didn't really care whether they had the skill sets or not. Regardless of whether they had the skill sets, they didn't need to have the skill sets for the amount we were paying for them. And we would just throw scripts out and get them to run and have the results come back. And because people didn't understand the application that they were running scripts against, you find more errors. You had to be very clear. It was a very messy process. When ideally, when you're writing test scripts, you probably wanted to automate this in the first place, but for whatever reason couldn't. And also, the fact that we've prioritized them in the scripts and the fact that we talk about running them is very much an automatizable set of language elements. That's how we describe when we've automated processes. Those are the same types of words that we use. So if we then look at the reporting process, it fell out directly from the execution. It didn't fall out of the modeling, it fell out of the execution. And we have this notion of test completion, the defect reports coming out, and we record everything, metrics. And working back from that, it would be very easy to automate that. If we had a tool where we put all our results in, where we tracked all the scripts we were doing, where we planned them, it's very easy to come up with how much testing have we done, what percentage of the scripts have we executed, what is our total coverage against the scripts or cases that we said we were going to do, how much have we still got left to do, given how much we've done and how much we've still got to do, what do we think is left? Given how much we said we're going to do and how many defects we've got, we might even be tempted to calculate percentage of defects left in the rest of the system that we haven't covered yet. All of that kind of falls out of this notion of the, well, let's at least automate this bit. Let's get some value out of this. And then what's interesting is this isn't really information. This is data. This is automatically generated stuff from a process. In order to get information out of this, we still have to analyze it, conceptualize it, compare it against models, make decisions, take it to planning meetings, agree, blah, 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 blah. But this itself is not really giving information. I think it's giving data. Now, if you were really set on trying to automate as much of this process as possible, you now have a pretty good start for doing that. And if you look at the entities that are in here and compare them against kind of standard testing tools, you'll see that this is almost why we have this. We couldn't automate the execution because the languages weren't there, the interaction capabilities weren't there, it was too expensive. But we could at least, if we had people involved, track it in more detail and automate the data coming out of this and build loads of graphs and metrics. It'll be brilliant and we'll easily see what's going on. Now, you can see that from here, we haven't really got a coverage model because we've got rid of the referencing back to the modeling component. So in order to really report on coverage, we need to get those test conditions back in because that's the real human part where we were discovering what we were actually going to test and how it relates back to our model of the system to try and get some sort of information coming out the back and not just data. So let's put that back in, because really what we want is we want to map back from scripts to cases so that when we say this script has run, this test case has run, and that implies that these conditions have been partially met. And if you look at this model, this ties on very closely to a lot of the early test management and test modeling tools, and possibly some of the tools that are still in use now. But it doesn't really capture the essence of testing, which was that modeling part, the exploration of the system and comparing our results and observations back to the model and reporting on what we found. But it's also very easy to see at this point that so much of that we implemented in tools, and it would just take that little bit extra effort to have those scripts automatically executable, and then we've essentially automated most of this testing process. We've automated a lot of this testing because it's all still called test execution, test reporting, test analysis. We've got test all the way through this, and it was test that was driving this. And we're ignoring the fact that at some point we're going to build in a unit test. At some point we're going to try and automate from the development process up and start automating within the development process and start using that as part of our test process. So it's very easy to understand how we might start thinking about this in terms of as a test automation process. So if I put the modeling component back in, we can see that in the model we've got requirements, documentation, we've got flows. All of those are pretty easy to model in advance and understand. And if we were doing model-based testing, where we try and automate based on a model, the flows come in at that point. We may not really have covered the structural elements, the architecture. We probably haven't codified risks, right? Because that's not something we always want to check for, right? Specific ad hoc risk. I wonder if we've done that. I wonder if we've got this issue. What happens when we scale it? We want to do these things periodically rather than all the time. But requirements is very important that we continually check whether our basic requirements in the system are still being met. So I'm going to put exploration back into this model. So now what we see is we've got this modeling process in parallel of this standard formal process. And we very often did this, right? We'd have test conditions, test cases, test scripts, and we'd start working through it and we'd discover we had gaps. And you wouldn't necessarily want to go and create new cases, conditions, and write new scripts for it. You'd go away and do something and see if there was a problem. And if you start finding areas and it looks like it's risk or it's much bigger than you thought, then you go back and you start writing conditions and things for it because the process was getting in the way. But we fundamentally always had to do this when we were testing. But it's very hard to automate this process because we're working from risks, we're working from structural analysis, we're still dealing with requirements, but we're pushing the data boundaries way beyond what we codified in the test cases because we can do it faster and we can have an idea, check that it works, document what we've done and build up a coverage model that way. And then we're reporting on the information there and feeding that back into the test reporting process. But then if we still want to automate a lot of this because we've got a lot of work to do and we don't want to continually do this stuff all the time. What does that mean? Because we're not really automating that ad hoc modeling exploration process. What we're doing is we're coming up with a smaller model, a subset of our model that we can automate, something that is automatizable. We're looking through that model, and chances are it's requirements, documentation examples, flows. Now a lot of this feeds into specification by example, BDD, acceptance test driven development. All of that, those are things that we can automate. We can come up with codified examples that we want to continue to check, see whether they work because they're very important. And we'll still do a lot of modeling and exploration on the side to get more information than we actually thought. But we want this parallel set of, we want to consistently automate conditions to see whether this system keeps doing what we thought it would do in the first place. But we've still got the issue here that we've called all this still test analysis, test execution, test reporting. It still seems like it's part of our, it is part of our test process because it's we're doing software development. We have a test process to check whether this application is working as we expect. So it still forms part of our test process, but we've labeled all this test. So it seems like we're trying to automate testing, and then we might forget about the exploration part and we might only focus on the automatizable parts. So what if we codify that distinction in our model? We have an automatizable model. We have a subset of our bigger model that we can automate. Now we have a model that does look a bit more like an agile type test process, where we've still got all our modeling. We've created subsets of it of things we want to continue to see working. These are our automatizable requirements, whether it's BDD, ATD, specification by example, whatever it is we're doing, but it's a subset of things. It's not necessarily always the risks, because we'll test those through exploratory testing, but examples, flows, use cases, stuff that scenarios that people understand, we'll put those in. But then it's not really test analysis, it's automatization analysis. How are we going to automate this? What exact data? How are we going to put that data in? And we might come up with specific conditions that we want to see under there and specific example cases of data that we want to see flow through. And the automated execution is us writing a script. And we'll collate those scripts into suites so that we can try and chunk this out, and so that we can also run different suites in parallel. And some suites might run in different environments, and we might have that going through a pipeline. But those suites will run, and they will run on a regular basis. And then we will report on the results, because it's data. It's this particular script. Did it pass? Yes or no? We might give some sort of sense of coverage because we've modeled this in a human language, or we've modeled this in a scenario, and we can map it back to those because it's driven by those. The Gherkin flows are a form of coverage, and we can map back directly because that is driven through the automated process when we write the code to do it. But we still have in parallel the testing process, where we're doing exploration from a much bigger model than we could ever hope to automate. And when we communicate it, we're not just communicating data, we are communicating information. And in that sense, testing is an information provider, but not necessarily the automated part. And the automated part is part of our test process, but isn't really testing, and it isn't in this model test automating. It's automated execution of processes that we want to see because we want to cover these particular conditions on an ongoing basis. The language changes, the model has changed and is richer for it, and there's no reason why we couldn't have done this when we were doing waterfall projects, except for the fact that our tools very often didn't help us. And that's one reason why we've ended up in the language mess and argumentation about 100% test automation that we find ourselves in today. Now, these are just my models. These are just diagrams that I've created to help me think through this process, because I've been trying to work out what language we should use and how this works. So I hope that is useful for you. I will create a blog post that has all these examples in it, and feel free to use GraphViz and experiment with these models yourself. If this is useful, leave comments and let me know how this affected you.